amount they are demanding. That is important. What amount they are demanding. Okay. So here the example you see carefully, price of a commodity and amount demanded. Price of a commodity as well as amount demanded. Then increase in rainfall, see, up to a point and production of rice, etc. See, if the rainfall increases, the production of rice also increases. But that is up to a point only. Beyond that point, if the rainfall increases, automatically we are going to lose the production of the rice. Sometimes we are going to lose the basic investment also. So this is involving only two variables here. So first example is here, age of husband and age of wife. Price of a commodity and amount demanded. Increase in rainfall to a point and production of a rice. Okay. Then degree of relationship between the variables under consideration is measured through the correlation analysis. Degree of relationship between the variables. What is the degree of relationship? So for example, we want to see the relationship between the two variables. So for example, the degree, if it is more than 90%, the perfect high degree of correlation, we are going to say this way. If it is below 90, that there is a correlation between two variables. Okay. So the measure of correlation called the correlation coefficient or correlation index summarizes in one figure the direction and degree of correlation. Okay. The next over here, the correlation analysis refers to the techniques used in measuring the closeness of relationship between the variables. Okay. So we are going to see the closeness of the relationship between the variables. Then some important definitions of correlations are given by the different authors. So that is the definition. The number one is according to Simpson and Kafka. Correlation analysis deals with the association between two or more variables. Correlation analysis deals with the association between two or more variables. Okay. Then according to L.R. Kune, if two or more quantities vary in sympathy so that movement in one tend to be accompanied by corresponding movements in the others, then they are said to be correlated. According to Yalun Chow, correlation analysis attempts to determine the degree of relationship between variables. Okay. Then according to A.M. Tutel, correlation is an analysis of the covariation between two or more variables here. So Tutel says that here covariation between two or more variables. Then thus correlation is a statistical device which helps us in analyzing the covariation of two or more variables. So here the problems of analyzing the relation between different series should be broken into three steps. That is determining whether a relation exists and if it does, measuring it, testing whether it is significant, establishing the cause and effect relation if any. Okay, so these are the way to analyze the problem. So determining whether the relation exists or not. So we have to check whether the relationship is existed or not based on the degree of correlation. If the value is a positive, then we can say that there is a perfect positive relationship. If the value is a negative, then we can say there is a negative relationship. Sometimes the value will be zero. Then we can say that there is no relationship between the two variables. Then testing whether it is significant. So test whether it is important or not. Then establishing the cause and effect relation, if any. Okay. Then the next one is significance of the study of correlation. The study of correlation of immense use in practical life because of the following reasons. So that is here, most of the variables show some kind of relationship. For example, there is a relationship between price and supply. See, most of the variables show some kind of relationship. That is, there is a relationship between the price and supply. So if the price increases based on the requirement, the customer demand the product. If the customer demands more, then immediately the supply also increases. Then income and expenditure. Income and expenditure also relationship. When your income is high, then you will take a decision to purchase different products, and there is a chance to incur some expenditure. When your income is high, automatically expenses also increases. If your income is less, then you are not, you are in a position to create an expenditure. But the thing is here, the situation is demand not demands to purchase any item. That is income and expenditure. Then next over here, with the help of correlation analysis, we can measure in one figure the degree of relationship existing between the variables. Okay. Once we know that two variables are closely related, we can estimate the value of one variable given the value of another. This is known with the help of regression analysis. Okay. So the next one here, correlation analysis contributes to the understanding of economic behavior, aid in locating the critically important variable on which others depend, may reveal to the economist the connection by which disturbances spread and suggest to them the paths through which stabilizing forces may become effective. Okay. Then next, in business, correlation analysis enables the executive estimate cost, sales, prices, and other variables on the basis of some other series with which these cost, sales, and prices may be functionally related. Some of the guesswork can be removed from the decision when the relationship between variables to be estimated and the one or more variables on which depend are close and reasonably invariant. Okay. So, however, it should be noted that coefficient of correlation is one of the most widely used and also one of the most widely abused statistical measure. Then here it is abused in the sense that one sometimes overlooks the fact that correlation measures are nothing but the strength of linear relationship, and that is does not necessarily imply a cause effect relationship. Progressive development in methods of science and philosophy has been characterized by increasing in the knowledge of relationship or correlation. So here progressive development also in science and philosophy. In nature also, one finds multiplicity of interrelated forces. The effect of correlation is to reduce the range of uncertainty. The prediction based on the correlation analysis is likely to be more valuable and near to reality. Here, the predictions, okay, the prediction based on the correlation analysis is more likely valuable and near to the reality. Okay. The next here, so types of correlation, this is a very much important question. So my dear students, please note down, the question will be like this: what define correlation and explain the different types of correlation analysis. So correlation analysis types, so you see the these types here. Correlation is described or classified in several different ways. The first one is positive or negative correlation, simple, partial, and multiple correlation, linear and non-linear correlation. Okay. How many types there? There are positive, negative, simple, partial, and multiple, linear, and non-linear. Positive and negative correlation. Whether correlation is positive, direct, or negative, inverse, would depend upon the direction of change. If one variable is increasing, the other on an average is also increasing. Or if as one variable is decreasing, the other on an average is also decreasing. Correlation is said to be positive. So for example, here one variable is increasing. For example, x variable is increasing here. See 10, okay, 12, 10, 12, then 15, 18, 20. So it is increasing. On the other side, y also increasing 15, 20, 22, 25, 37. On an average, it is also increasing. Then over here, say 80, x values 80, 70, 60, then 40, then 30. It is decreasing. Y also decreasing here. 50, 44, 30, 20, 10. So always the positive correlation should be either X value or Y value. X value is increasing in the same manner on an average, Y also increasing. Then it is a positive correlation. In the same manner here, X is decreasing, Y also decreases. Okay. If on the other hand, the variables are varying in opposite direction, that is one variable is increasing and other is decreasing or vice versa, correlation is said to be a negative. So here see positive correlation, one is slowly increasing in this way. Slowly it is moving towards a right direction. In the same manner, Y also increasing slowly on an average. It is also decreasing towards a right direction. Here, the left side, it is decreasing here, like this. Okay, so the next one is negative correlation. In negative correlation, what happens here? X variable is increasing, but the Y variable is decreasing. And X variable is decreasing, Y variable is increases. So you see this example. Okay, you observe the table carefully. See, 20, 30, 40, 60, 80. They are increasing. Then 40, 30, 22, 15, 10. They are decreasing. So here one is moving towards right direction. The other is moving towards left direction. This is negative correlation. So other is decreasing the value. The next one is increasing the value. 100, 900, 60, sorry, 100, 90, 60, 40, 30. See, it is slowly decreasing 10, 20, 30, 40, 50. It is increasing. This is negative correlation. Whether it is a positive direction, one is increasing, one is decreasing. One is increasing, other is decreasing. Okay. This is about the negative correlation. Then next over here, simple, partial, and multiple correlation. The distinction between simple, partial, and multiple correlation are based upon the number of variables studied. When variables are studied, it is a problem of simple correlation. Only one variable. So here when only see distinction between simple, partial, multiple correlation are based upon the number of variables studied. When only two variables are studied, it is a problem of simple correlation. For example, see X and Y. X and Y. Only two variables are there. So we studied these two variables. This type of problem is called as simple correlation. When three or more variables are there, variables are studied, it is a problem of other multiple or partial correlation. In simple correlation, three or more variables are studied simultaneously. X, Y, and Z. Okay. So we see with examples also. See, when we study the relationship between the yield of rice per acre and both the amount of rainfall and the amount of fertilizers used, it is a problem of multiple correlation. Relationship between the yield of rice per acre and both the amount of rainfall and the amount of fertilizers we used. See, this is the yield of rice, amount of rainfall, amount of fertilizers. We studied at a time these three variables. This type of problem is called as multiple correlation. Multiple correlation. Multiple correlation. The next one here, see, on the other hand, in partial correlation, we recognize more than two variables, but consider only two variables to be influencing each other, the effect of other influencing variables being kept constant. In Rice problem taken above, we limit our correlation analysis of yield and rainfall to periods. When a certain average daily temperature exists, it becomes a problem relating to simple correlation. Okay, so here what happens here? In multiple correlation, three variables studied at a time. In partial correlation, more than two variables are there, but we are going to consider only two variables. Okay, right. The next, linear and non-linear correlation. Linear and non-linear correlation. So the distinction between linear and non-linear correlation is based upon the constancy of the ratio of change between the variables. If the amount of change in one variable tends to bear the constant ratio to the amount of change in the other variable, then the correlation is said to be linear. Okay. See, if the amount of change in one variable tends to bear the constant ratio to the amount of change in other variable, then the correlation is said to be linear. For example, observe the following two variables, x, y. See, x variable is a 10, 20, 30, 40, 50. And y variable 70, 140, 210, 280, then 350. See, x variable values are increasing towards right direction. In the same manner, y variable also here a constant ratio, the amount of change in the other variable, that is 70, 140, 210, 280, 350. It is clear that the ratio of change between two variables is same. If such variables are plotted on a graph paper, all the plotted points would fall on straight line. Okay, then correlation would be called nonlinear. In linear, what happens here? What amount of change in x variable on an average, the and y variable also there is a change. So see, you observe carefully. See like this, if you plot it on a graph sheet, see 10, 20, 30, 40, 50, 60, 70, 80. And here 70, 140, 210, 280, 350. Okay, in this way. So if it is, see like this, straight line will be there if it is plotted on a graph paper. So this type of problem is called as linear correlation. Linear correlation. Then over here, next one is here. Correlation would be called non-linear or curvilinear. Non-linear, or sometimes we call it as a curvilinear. If the amount of change in one variable does not bear a constant ratio to the amount of change in other variable, correlation would be called non-linear or curvilinear. If the amount of change in one variable does not bear the constant ratio to the amount of change in other variable. Okay, so say linear, you see the example 10, 20, 10, 20, 30, 40, 50. In the same manner, 70, 140, 210, 280, 350. If this type of situation is not repeated, then we call it as a non-linear or curvilinear problem. For example, if we double the amount of rainfall, the production of rice or wheat, etc., would not necessarily be doubled. Okay, if we double the amount of rainfall, the production of rice and wheat would not be double. it may be pointed out that in the most of the practical situation, we find a non-linear relationship between the variables. Yes or no? For example, you cultivated the land in the plot, the regarding only paddy or wheat. If the rainfall is every day, there is a rainfall. Then what amount of crop we are going to yield, sometimes it will increases, but it not be doubled. It may be pointed out that in the most of the practical situations, we find a non-linear relationship between the variables. However, since techniques of analysis for measuring non-linear correlation are far more complicated than those for near correlation, we generally make an assumption that the relationship between the variables is of linear type. Yes, is of linear type. So these are the types of correlation analysis. Then now we are entering into probability part. Okay. See, measures methods of studying correlation. The various methods of ascertaining whether two variables are correlated or not. The commonly used methods for studying the correlation between two variables are here. Okay, so wait a minute, I will be back in 1 minute. So here the types. So what is there in our syllabus? We will see. The first one is scatter diagram method, graphic method, Carl Pearson coefficient of correlation, rank correlation, concurrent deviation, probable error, then coefficient of determination, lag and lead correlation. Okay, so we'll see today what amount of problems we are going to complete. We'll see. So for scatter diagram method and a graphic method, these are different types of methods are there. So Carl Pearson coefficient of correlation. See, scatter diagram is there, all the methods are there. So, but the important points we are going to study. See, wait a minute. So we'll see Carl Pearson coefficient of correlation topic. It was a very much interesting topic. It is. Yeah. So we'll see first that is important topic only I am focusing. Carl Pearson's coefficient of correlation. Right. So a mathematical method for measuring the intensity, or the magnitude of linear relationship between two variable series suggested by the Carl Pearson's 1867-1936, a great British biometrician and a statistician. Carl Pearson's methods, popularly known as Pearson's coefficient of correlation, is most widely used is in practice. So here, the Pearson's coefficient of correlation is denoted by the symbol R. Okay, is denoted by the symbol R. It is one of the very few symbols that are used universally for describing the degree of correlation between two series. This method is to be applied only where deviations of items are taken from actual mean and not from the assumed mean. Okay, so you observe carefully after solving the problem. The value of coefficient is obtained by the above formula shall be always lie between plus or minus 1. When r is equal to plus 1, it means there is a perfect positive correlation between the variables. When r is equals to minus 1, it means there is a perfect negative correlation between the variables. When r is equals to 0, it means there is no relationship between the variables. However, in practice, such values of r as plus 1, minus 1 and 0 are rare. We normally get values which lie between plus 1 and minus 1, such as plus 0.8, minus 0.26, etc. The coefficient of correlation describes not only the magnitude of correlation but also its direction. Thus, plus 0.8 would mean that correlation is positive because the sign of R is plus and the magnitude of correlation is 0.8. Similarly, minus 0.26 means a low degree of negative correlation. So here the following formula for computing Karl-Pearson coefficient of correlation is so here very easy to apply. Okay, so you first before we are going to see the formula, first you should know this one. The Karl-Pearson's coefficient of correlation is calculated by two methods. They are as follows: actual mean method, assumed mean method. So actual mean. So what is actual mean? So here in the actual mean method, R is equals to sigma xy divided by under root sigma x square into sigma y square. Sigma xy divided by under root sigma x square into sigma y square. Okay. R is equals to sigma xy divided by under root sigma x square into sigma y square. Then actual mean and assumed mean. So we'll see the problems on actual mean method. So calculate Karl-Pearson's coefficient of correlation from the following data and interpret its values. Roll number of students, marks in accountancy, marks in statistics. So here rule number of students 1, 2, 3, 4, 5. Marks in accountancy 48, 35, 17, 23, 47. Then marks in statistics. So the question will be like this. So after observing the question properly, first we have to take a decision that this problem belongs to actual mean or assumed mean. Okay. So simply see, let marks in accountancy be denoted by X and marks in statistics be denoted by Y. So rule numbers are there 1, 2, 3, 4, 5. So simply I'm copying the question here like this. You observe carefully. X 48, 35, 70, 23, 47. Then Y 45, 20, 40, 25, 45. Okay. Then immediately, see, we copied the values, these variables from the question paper. Then after we have to take a decision that whether this problem belongs to actual mean or assumed mean. So to know that, first what you have to do, you observe carefully. We need to find out the average of this value. That is 170 divided by 5. 170 divided by 5 means here x bar. This is x bar. So we have to do this step. 170 divided by 5. That is 34. And y bar means here 175. This value. 175 divided by 5. That is 35. So you observe carefully, 34 and 35. 34 and 35. So we got the values in the both in the two cases. 34 in the first case and 35 in the second case. So we didn't get like this value, that is 34.5 or 35.6. No decimals we got in the given average values. So what we have to do? So in these two situations we didn't got any decimal value. So this problem belongs to actual mean. We have to take a decision according to this average values. Then after, the next is x is equals to x minus x bar. Okay. X is equals to 34. So simply 48 minus 34, that is plus 14. 35 minus 34 plus 1. 17 minus 34, that is minus 17. 23 minus 34. Okay, minus 11. 47 minus 34, that is plus 30. Sigma x is equal to 0. Then we got x values. 14 square, 1 square, 17 square, 11 square, 13 square. 196, 1, 289, 121, and 169. Sigma x square is equal to 776. Okay. Then the same procedure apply for y case also. Y minus y bar. Y is equal to 35. 45 minus 35, that is plus 10. 20 minus 35, that is minus 15. 40 minus 35, that is plus 5. 25 minus 35, that is minus 10. 45 minus 35, that is plus 10. And finally we got 0. Then y square. 10 square, 100. 15 square, 225. 5 square, 25. 10 square, 100. 10 square, 100. Sigma y square is equals to 550. Then y into, sorry, sigma, so we completed y square also. X into y. X values are 14, 1, 17, 11, 13. Y values are 10, 15, 5, 10, 10. 14 tens are 140. 1 into 15 minus 15 minus 17 into plus 5 minus 85 minus 11 into minus 10, that is 110, minus into minus plus 13 into plus 10, that is 130. So after doing the calculation, we got sigma xy is equals to 280. So we got all the values. So according to the principle, R is equal to sigma xy by under root sigma x square into sigma y square. Okay. So according to the formula, we required values are here and they are calculated as follows. That is sigma xy is equal to 280, sigma x square is equal to 776, sigma y square is equal to 550. Then R is equal to sigma x by under root of sigma x square into sigma y square. So we done the calculation. Then finally the answer is here. R is equal to 0.429. So it is a positive correlation. So after getting these value, simply you write a conclusion that from the above figures, it is interpreted that there is a perfect positive correlation between marks in accountancy and marks in statistics. Okay, so if anybody have any doubt, you can raise your doubts. This is a problem for actual mean. So first, see here, note number one, that is under root 76 into 550. 76 into 550. First, you do multiplication, then you will get 4,26,800. So go for doing the under root. Then you will get 653.299. That is numerator divided by denominator. R is equal to 0.429 is the final answer. Okay. So these are the practice problem. So my dear students, please take a photo. Practice problems on actual mean. Completely actual mean problems. Making use of data summarized below. Calculate the coefficient of correlation. Case A, B, C, D, E, F, G, H, X1, X2, 10, 16, 9, 10, 12, 13, 11, 9, 9, 4, 6, 9, 11, 13, 8, 4. Okay. So you see how many problems are there? There are almost 7 problems are there. If you do practice these 7 problems, then you are going to get a complete command on the correlation analysis, actual mean method only. And it will show a roadmap to solve the assumed mean method problems also. If you practice, otherwise, you are listening the class. If you are not ready to do the practice, then you will feel uncomfortable in solving the problem in examination point of view. Okay, so these are the different important questions. They are covered, they are taken from the different universities examinations. See, calculate the Carl Pearson's coefficient of correlation between expenditure and advertising and sales from the following data given below. Advertising expenses, sales. Okay, only 2 variables are there here. So first what we do, we have to check the average value. Then after finding the average value, then go for taking a decision that the problem is also actual mean. So sometimes what happens, see, you see the problem number 4. This is important. From the following table, calculate coefficient of correlation by Carl Pearson's method. XY 6, 2, 10, 4, 8, 9, 11. Arithmetic means of X and Y series are 6 and 8 respectively. So for example, the average value is different value, but already in the question 6 and 8 is given. So what we have to do, we have to consider 6 and 8 only. 6 and 8 only we have to consider. Okay. So this is the actual mean problem. Then go for the assumed mean problem. The next procedure. Problems on assumed mean method. Assumed mean method. So you see the problem, assumed mean. The process. See, while we are calculating assumed mean method, we have to keep in our mind following few important points. Okay. So the process is common in this method also. Okay. Process is common in this method also. Then second point, that is we have to decide by observing the problem and calculate the average of X and Y variables. After calculating the average of X and Y variables, if we got the fraction values or that is decimal, that is 10.12 or 2.10 in any X and Y variables, then apply the assumed mean method. If the average values of X and Y variables are not in fraction, that is decimal, then apply the actual mean method. Okay, the following method and the formula is applied for assumed mean method. So what is the formula? We will see the formula. The formula is here: sigma dx dy minus sigma dx into dy under root divided by n. Sigma dx dy divided by sigma dx into dy divided by n. divided by under root sigma dx square into sigma dx whole square by n into under root sigma dy square minus dy whole square by n. Okay. So whereas here r is equal to coefficient of correlation, dx dy sigma dx dy, the sum of product of the derivation of x and y series from the assumed mean. Sigma dx square is equal to sum of squares of the derivation of x series from the assumed mean. Dy square, assume sum of squares of the deviations of y series from the assumed mean. Dx, that is sum of deviations of x is from assumed mean. And sigma dy, sum of deviations of y is from the assumed mean. Then n stands for number of pairs or observations. So we go for the problem. So you see the problem. Problem is very much important. Calculate coefficient of correlation for ages of husband and wives. Age of husband in years, that is 23, 27, 28, 29, 30, 31, 33, 35, 36, 39. Age of wife, that is in years, 18, 22, 23, 24, 25, 26, 28, 29, 30, 32. So this is the given question. So it looks very common. In the given question, actual mean or assumed mean is not mentioned by the examiner. We have to take a decision. Okay. So as it is, we have written here age of husband x, age of wife y. Dx is equals to x minus a, then dy is equals to y minus a. A is equals to 30 and a is equals to 25. So how we got this 30 and 25 is important here. So 311 and 257 are the total of husband age and wife age. So first we have to find out the values. Okay, so in this problem, the values are not given. So 311 divided by x bar is equals to, you observe carefully, x bar. Three hundred and 11 divided by 10. 31.10 and 25.7. So we got the decimal values. So from these values, you observe carefully. From these values, you can assume any number. You can take any number. So we have chosen this. The condition is that if you want to take 23 or 27 or 28, 29, 30, 31, 33, 35, 36, 39, that is your wish. You can take any number. But the condition is that here, if you want to take for the first value in x, the same case apply for the y also. 23 you chosen, and in x case, in y case you have to choose 18 also. So you're 30 and 25 here. So that is 23 minus 30 minus 7, 27 minus 30 minus 3, 28 minus 30 minus 2, 29 minus 30 minus 1, 30 minus 30 that is 0, 31 minus 30 that is 1, 33 minus 30 that is 3, then 35 minus 30 that is 5, 36 minus 30 that is 6, 39 minus 30 that is 9. So sigma dx is equal to 11. Okay, same apply for the y also. So you observe carefully, 18 minus 25, 22 minus 25, 23 minus 25, 24 minus 25, 25 minus 25, 26 minus 25, 28 minus 25, 29 minus 25, 30 minus 25, 32 minus 25. So you got 7. So then these values are called dx dy. Then dx 7 square 49, 3 square 9, okay, 2 square 4, 1 square 1, 0 square 0, 1 square 1, 3 square 9, 5 square 25, 6 square 26, 9 square 81. So sigma dx square is equals to 217. 217 is the sigma dx square value. Yes? Any doubt, anybody? No doubt. Okay. Then that is dy. So 18 minus 25, 17 minus 3 minus 2 minus 1, 0, 1, 2, 1, 3, 4, 5, 7. 7 square 49, 3 square 9, 2 square 4, 1 square 1, 0 square 0, 1 square 1, 3 square 9, 4 square 16, 7, 5 square 25, 7 square 49. So dx into dy. So dx values are here 7 and dy value are 7. 7 sevens are 49, 3 threes are 9, 2 twos are 4, 1 into 1 that is 1, 0 into 0 0, 1 into 1 1, 3 threes are 9, 5 4s are 20, 5 6 5s are 30, 9 sevens are 63. So we got all the values. Okay. The next step is here. After getting all this value, first to calculate averages of x and y to know the actual mean method or assumed mean method. So after calculating all the values, then substitute into formula as follows. That is the formula is here. R is equals to sigma dx dy minus uh, sigma dx into dy minus sigma dx into dy divided by n under divided by under root sigma dx square minus sigma dx whole square into under root sigma dy square minus dy whole square by n. So here sigma dx dy, sigma dx into dy that is 186. Okay, 186 minus 11 into 7 by 10 divided by 200 under root 215 into 11 whole square by 10 into under root 163, 7 square minus 10. So after doing all the calculation, finally, see how many steps I have written? 1, 2, 3, 4, 5, 6, 7. Finally, we got the answer is 0.99. 0.99. Numerator is 178.3. Denominator is 179.10. And finally, you got the answer is 0.99. So the conclusion is here from the above figures, it is interpreted that there is a perfect positive correlation between husband age and wife age. Okay, this is a actual mean as well as assumed mean problems. So we completed Carl Pearson coefficient of correlation problematic part. Then next problems for practice. These are the problems for practice. That is calculate the Carl Pearson's coefficient of correlation between price and demand from the data given below. This price and demand. Then Carl Pearson's coefficient of correlation between x and y from the following data: x series, y series. Then compute Carl Pearson's coefficient of correlation in the following series relating to the cost of living and wages. Wages, cost of living. Calculate the Pearson's coefficient from the following data using 44 and 26 respectively has the origin of x and y. So sometimes the examiner will give 44 and 26 like this. So at that time, no need to take any assumed value. Any assumed value. Okay. So this is the situation. The next one, you observe carefully. So when 44 and 26 are given, then immediately we will take these 44 and 26 for a for subtracting the values. Then the last one is Carl Pearson coefficient of correlation from the following data. Take 65 and 70 as the assumed average of variables x and y respectively. Okay, this is the assumed mean problems. So till this, if you have any doubt, anybody, you can ask the doubt. Okay, right. The next one is Spearman's rank correlation coefficient. Okay, this is also very much interesting and important topic. Charles Edward Spearman, a British psychologist, developed a method to find out the coefficient of correlation by assigning a rank to each value of variable or groups. This method is especially useful when quantitative measures of certain factors involving quantity or quality, okay, cannot be fixed. Okay, so here the individuals belonging to a group can be arranged in order by assigning a number indicating a rank to each individual of the group. Cases involving the evaluation of leadership skills and ability of an individual or the judgment of the female beauty. Female beauty and the like may make use of this method. So you observe carefully. Right. So see, the rank correlation coefficient also lies between -1 and +1. That is -1 less than or less than +1. When r is equals to +1, it can be inferred that there is a complete agreement in the order of ranks, and the ranks are in the same direction. On the other hand, if r is equals to -1, then it can be inferred that there is a complete agreement in the order of the ranks, and the ranks are in the opposite direction. The problems in rank correlation are of two types, that is, problems when actual ranks are given, problems when ranks are not given. When ranks are given, when ranks are not given. So the first method is here, problems where actual ranks are given. The following is the procedure for calculating the rank correlation coefficient for problems where actual ranks are given. So here the first one is calculate the difference D of two ranks R1 minus R2, square the difference and calculate the sum of differences, that is sigma D square. Substitute the values obtained in the formula. The formula is here. Spearman rank correlation coefficient is equals to 1 minus 6 sigma D square, 6 sigma D square divided by n into n square minus 1. Okay, this is the one problem. We'll see the problem now. The following example problems, the procedure for calculating rank correlation. The procedure for calculating the rank correlation coefficient. The first problem here. The rankings based on the efficiency of 10 employees working on two production coefficient. So here the ranks are based on efficiency, that is students A, B, C, D, E, F, G, H, I, J. 10 employees there. Process 1, process 2, 10, 12, 1, 4, 3, 6, 5, 8, 9, 7. Then process 2, 9, 4, 2, 3, 1, 5, 6, 8, 10, 7. Okay. So the calculate coefficient of rank correlation and comment on the value. Okay. So let the rank given efficiency of 10 employees working on two production as a rank of process 1 divided by X, and the rank of process 2 So here you observe carefully. So we need to find out di square values. After getting the di square value, apply the formula. That is, since n is equal to 10, sigma d square is equal to 15. Apply the above formula. We get the value like this here. Okay. So you see, observe carefully the calculation part. Yes. Okay. So this is the calculation part. After completion of this calculation, see what we got. We got here 0.90. So comment, the high positive value of rank correlation coefficient indicates that there is a very good amount of agreement between process 1 and process 2. Okay, in this way we have to do the problem. So when equal ranks are not given, equal marks are not given, then we have to apply this formula. This is a method 1 in rank correlation. Then we go for this second method when equal ranks are given. Okay, so you observe carefully. In some cases, it may be found necessary to rank two or more individuals or entries are has equal. In such a case, it is customary to give each individual an average rank. Thus, if two individuals are ranked equal, at fifth place, they are each given the rank that is 5 plus 6 by 2, that is 5.5. In other words, where two or more items are to be ranked equal, the rank assigned for the purpose of calculating coefficient of correlation is the average of the ranks which these individuals would have not, they differed slightly from each other. When equal ranks are assigned, the adjustment consisting of adding 1 by 12 m cube minus m is required. When equal ranks are assigned, the adjustment consisting of adding 1 by 12 m cube minus m is required. When where m stands for number of items whose ranks are common. If more than one such group of items with common ranks exist, this value is added as many times the number of such groups. The following formula can be applied. So this is a formula that is 1 minus 6 sigma d square, 6 sigma d square plus 1 divided by 12 m cube minus m plus 1 divided by 12 m cube minus m plus 1 divided by 12 m cube minus m. If the same rank is repeated number of times, in this way we have to add 1 by 12 m cube minus m, okay, divided by n into n square by this 1, okay. So here you observe carefully. Compute the coefficient of correlation, rank correlation between economics marks and statistics marks has given below. Eco marks, statistics marks 80, 56, 50, 48, 50, 62, 60. Then statistics marks 10, that is 90, 75, 75, 65, 65, 50, then 65. Okay, the next solution here. So in this case, tied ranks are more than one students share the same marks both in economics and statistics. So you observe carefully what happens here in a classroom, number of students are there and the competition is huge. Then the chances are there to get the same marks by different students. Okay, for example, you observe carefully the given question, echo marks are there 80, 56, 50, 48, 50. See 50, 50, we got two equal marks. Then 75, 75, 65, 65, again 65. Okay. So for economics, the students receiving 80 marks gets rank 1. One getting 62 marks receives rank 2. The student who secured highest marks, for them we are going to give a rank number 1. The second highest rank number 2. The student who get 60 receives rank 3. The students with 56 marks gets rank 4. And since there are two students each getting 50 marks, each getting 50 marks, each would be receiving a common rank. The average of next two ranks, that is 5 and 6, 5 plus 6 divided by 2 is equals to 5.50. And lastly, the last rank, that is rank number 7, goes to the student getting the lowest economic marks. In a similar manner, we award ranks to the students with statistical marks. So you observe carefully. So we copied the question from the question paper. It is very simple. These are the economics marks and these are the statistics marks. So giving the ranks here. So highest marks, that is in economics 1. See the second highest is here 56, 50, 48, 50, 62, 60. So second highest is here 62. 62.
Partner. ఇప్పుడు స్విగ్గీ మీకు
So the next one is here third, then fourth, completed. Then fifth and sixth, 5 plus 6 is equal to 11 divided by 2, that is 5.5, 5.5. So for rank number, so we are not giving the rank 5 and rank 6. Simply we are giving a common rank, that is 5.5, 5.5. Okay, any doubt anybody? 5.55. This is the important when comparing with when equal ranks are not given. That is 6 sigma d square by n into n square minus 1. 1 minus. Okay. So this is important. This point you should remember. Then you are going to solve the problem in rank correlation when equal marks are secured by two students. Okay. This is that one. Then next over here, ranks for statistics yi. Okay. Again, that is a 90 marks. A student who secured, that is highest. So I'm giving the rank 1. Then second highest 75, 75. 75 and 75 here. You observe 75, 75. So 2 and 3. 2 plus 3, that is 5, 5 by 2, that is 2.5 and 2.5. Okay. Then 65, 65. 5, 5. Then 50, 65. 7, 5. So we have given the ranks to all the economic students and ranks for statistics students. Then DI, that is XI minus YI. 1 minus 1, 0. 4 minus 2.5, 1.5. 5.5 minus 2.5, that is 3. 7 minus 5, that is 2. 5.5 minus 5, that is 0.5. 2 minus 7, that is minus 5. 3 minus 5, that is minus 2. Okay. DI square, that is 0. 1.5 square is equal to 2.25. 3 square 9, 4 square 4. 2 square 4. 0.5 square 0.25. 5 square 25, 4 square 4. Sigma di square is equals to 44.5. 44.5 sigma di square. This is a final answer. So after getting this answer, okay, after getting this answer, take the formula and implement the values into the formula. For economics marks, there are one tie of length 2, and statistics marks, there are two ties of length 2 and 3 respectively. Thus, so 1 minus 6 sigma d square plus 1 by 12 m cube minus m plus 1 by 12 m cube minus m. So 6, that is 6 into 44.50 plus 1 by 12 m cube. M, how many ties are there in the first x variable economics marks? 2 ties are there. 2 cube minus 2. Okay, 2 cube minus 2. Then in marks in statistics, how many ties are there? 3 ties. So m cube minus m. 3, that is, yes, 2 and 3 is there. Sorry. So this is another important. See, my dear students, you observe carefully. So this is 1, 2 ties, 5.5, 5.5. 2 ties we written here, we completed. See this one. Then next, 1 and 2. So 2 cube minus 2, then 1, 2, then 3. So 3 cube minus 3. 3 cube minus 3. So this is important. So in the economics marks, one rank repeated 2 times. In statistics marks, one rank repeated 2 times and another rank repeated 3 times. 2 students got same marks and 3 students got the same marks. So 1 minus 6 sigma 6 sigma d square plus 1 divided by 12 m cube minus m plus 1 by 1 divided by 12 m cube minus m. So 1 into, see, 1 minus 6, 44, 60 to 44.50 plus 1 by 12, that is a 2 cube minus 2 plus 1 by 12, 2 cube minus 2 plus 1 by 12, 3 cube minus 3 divided by n into n square minus 1, 7 into 7 square minus 1. So with the simply go for calculating all the values. So after calculating all the values, you observe carefully, 1 minus 6 into 47.50 divided by 336. 1 minus 285 divided by 336. So final answer is 0.152. 0.152 is the answer. So this is a way of calculating a Carl Pearson coefficient of correlation for a correlation analysis. Okay. The next, actual mean, assumed mean, then rank correlation. In rank correlation also 2 types. That is, the type 1 is the when equal ranks are not given, when equal ranks are given. Okay. So remember important points, my dear students. When equal marks secured by a student, then we are going to give the same ranks to the students. Okay, so the calculation part is important here. Right. So anybody, if you have any doubt, you can ask the doubt also. So, right. Concurrent deviation. The next important method is concurrent deviation. Coefficient of concurrent deviation. A very simple and casual method of finding correlation. When we are not serious about the magnitude of two variables, is the application of concurrent deviations. This method involves in attaching a positive sign for x value, positive sign for a x value, except the first. If this value is more than the previous value, and assigning a negative value, if this value is less than the previous value, this is done for the y series as well. The deviation in the x value and the corresponding y value is known to be concurrent. If both the deviations have the same sign, in this method, we need to know the direction of change of x and y variables. So simply signs we are going to indicate, denoting the number of concurrent deviation by C, and total number of deviation has n, which must be 1 less than the number of pairs of x and y values. The coefficient of concurrent deviations is given by RC is equals to plus R minus. So this is a formula, plus R minus under root plus R minus 2C minus n by n. So where RC is equals to coefficient of concurrent deviation, coefficient of correlation by concurrent deviation. Okay. C is equals to number of concurrent deviations. N is equals to total number of items minus 1. Uh, like Pearson's correlation coefficient and Spearman rank correlation coefficient. The coefficient of concurrent deviation lies between -1 and 1, both inclusive. So you first we are going to see the problem. So these are the different steps. The following steps are used. Firstly, we see the direction of change in x variable. For this, we compare the first value of variable x with the second and see whether the second value is increasing or decreasing or constant. If it is increasing, we put a positive sign. If it is decreasing, we put a negative sign. And if it is a constant, then we put a 0. Similarly, as compared to the second value, see whether the third value is increasing, decreasing or constant. Report this process for all other values. Denote this column by dx. Similarly, we find the direction of change of y variable and denote it by dy. Okay. So these are the steps. So we go for the problem. Then while we are doing the problem, we will get the doubts are clarified. So before that, we'll see multiple dx and dy and determine the value of c, that is number of positive sign. Apply the formula. The purpose of putting place minus sign inside the root is that if it is negative, value must be multiplied by minus inside the root so that it may become positive and we can take the root. The purpose of putting plus and minus sign outside the root is to show the ultimate result with its original sign by multiplying the result with minus sign. If it is positive, then we would get positive value of coefficient of correlation. So this is a problem, coefficient of concurrent deviation problem. Calculate coefficient of concurrent deviation from the following data: xy 360, 364, 372, 384, 366, 370, 378, 392, 386. And y values are 492, 480, 460, 434, 466, 454, 430, 390, then 400. Okay. So simply x values and y values are written here. See direction of change in dx, direction of change in dy, dx into dy. So this is very much important step here. So first value 360 is there. 360 is there. So there is no comparison. So leave this column empty. This column 492. Leave this column empty. And dx into dy, nothing is there means it is also we need to leave empty. Okay. Then now it begins. That is comparison. Okay. So you observe carefully. 360, 364. When we compare 364 with 360, value is increased or decrease? Yes, it is increase. So just to keep plus sign. With 364, 372 is there. Increase or decrease? Increase, plus sign. 372 and 382. Value is increase or decrease? It is increased. Again, plus sign. Then 382, that is 366. Value increase or decrease? Decreased. So simply minus sign. So 366, 370. Value increase or decrease? Increased. So plus sign. 370, 378. Value is increase or decrease? Increase. Plus sign. 378, 392. Value increased. Plus sign. 392, 386. Value is decreased. Okay. Value is decreased here. So minus sign. So this part we completed. This one completed. Then we go for the next one. Y. Okay. See direction of change dy. 492 and there is no comparison. So just leave empty. 492, 480. So 492, then 480. Value increase or decrease? Decrease. So just keep minus sign. Then 480, 460. Value increase or decrease? Decrease. So plus minus sign. 460, 434. Value decrease. Minus sign. 434, 466. Value increased. Plus sign. 466, 454, value decrease, minus sign. 454, 430, value decrease, minus sign. 430, 390, value decrease, minus sign. 390, 400, value increase or decrease? Increased, plus a sign. So after getting all these sign, then go for dx into dy. Plus into minus, only sign only again here. Plus into minus, minus, plus into minus, minus, plus into minus, minus, minus into plus, minus, plus into minus, minus, plus into minus, minus, plus into minus, minus, minus into plus, minus. So C is equals to 0. C is equals to 0. So here we need to consider only positive values only. So we got all the negative values, that is C is equal to 0 only. So here C is equal to 0, N is equals to 8. RC is equals to plus or minus under root plus or minus 2C minus N by N. Okay. We got minus 1. Minus 1. So comment is here. Perfect negative correlation is there. Perfect negative correlation is there. So anybody any doubt? Okay. I am moving to next problem. Okay, take a stab this problem. You do practice at home. What we discussed. Okay, if the problem is very simple, give it side only. Okay, with the previous value, the present value is decreased means just give plus sign. With the previous value, the present value is decreased means give minus sign. Then dx into dy2. These are the that is calculate the coefficient of concurrent deviation from the following, that is xy 60, 65, 50, 56, 30, 70, 40, 35, 80, 80, then 75. Then y 65, 70, 35, 75, 63, 80, 35, 20, then 80, 60, 60. Okay, so here yeah. Okay, this is the problem and this is the solution also. So calculation for correlation concurrent deviation, that is 60 is 55, 50, 56, 30, 70, 40, 35, 80, 80, 75. Then 65, 40, 35, 75, 63, 80, 35, 20, 80, 60, 60. So all these are the different sign we got. Then just to add, see here 80, 80 and 80. The previous value, present value is not decreased. So 80 minus 80, 0. 0 minus sign, that is 0. So plus values, how many plus values are there? You observe carefully. 1, 2, 3, 4, 5, 6, 7, 8. 8 plus sign are there. So C is equals to 8. Okay, na? So here 8, C is equals to 8, N is equals to 10. RC is equals to plus or minus n plus or minus 2C minus n by n. 2 into 8 minus 10 divided by 10 is equals to 0.774. So comment is here, perfect positive correlation is there. Perfect positive correlation is there. Okay. The next here, the merits of concurrent deviation methods are there. So first, second, third. So first merit is that it is easy to calculate. It is simple to understand. This method can be fruitfully used when only type of correlation is to be computed. Yes. The demerits of concurrent deviation method. It is only a rough measure of correlation to calculate the presence or absence of correlation presence or absence or correlation. And this method cannot be used for further statistical analysis. This is demerit. Through this method, combine R cannot be calculated in case of different series. Okay, so this we are going to wind up today. In the next Saturday, we'll start scatter diagram method. From this scatter diagram method, we'll see in the next class. So these are the topics we have discussed today. In correlation analysis. Correlation analysis actual mean, Carl Pearson coefficient of correlation, actual mean, Carl Pearson coefficient of correlation, assumed mean. Okay, then concurrent deviation. So what homework problems have given for practice purpose? You do practice, my dear students. If you do practice, then you are going to become a master in this subject. Otherwise, you are going to lose high marks. You are not in a position to calculate the problem. You are not in a position to calculate even problems. So it is very difficult to calculate. Those who are present for my class, they will solve the problem very simply. Okay. And the what problems are there in these subjects are very difficult, as well as if you practice, it is very easy. Okay. So at this, I am closing. So you have the next class, my dear students. So at this, today we are going to wind up. So in the next class, we'll discuss the remaining part. The congruent division completed. Okay. Then scatter diagram is there. We'll see. So you have next class, cost accounting and control. Okay. So thank you very much. Thank you and one and all.